Okay, welcome to the NUPOC video study guide number 35. Let's look at question 10 in the graphing math section of guide 1. Here we have x as a function of y. So it's just kind of the inverse of what we normally have. So here it's a quadratic, so we're going to have a y squared term, right? And so x is going to be a function of y squared, so we sort of expect a parabola, and it's a positive y squared term, so we expect a parabola opening towards positive values of x, something like this, right? Alright, so let's go ahead and let's do it two ways. Let's do it where we keep it as x as a function of y, and then we'll flip it where it's y as a function of x. We'll do it again real quick, and we'll see that we get the same thing, just to show that we can do it. Alright, so let's start by finding any roots of this function. So let's break this out into its factors. So we've got 2 and y minus 2 and y minus 2, right? So it looks like we have a double root at y equals 2. So this is the point y equals 2 is where we will come down and x will equal 0 and we'll cross the y-axis, right? Looks like a double root right there. Let's go ahead and see if we have any critical points. So we'll take dx dy, and that will be 2 times 2 times y minus 2 times 1. This is by the chain rule here, taking the derivative of the y inside here. If we set this equal to 0, it looks like we have a critical point at y equals 2. Okay? Alright, so it looks like if we have a critical point here, then it looks like we're probably, if that's going to be a minima or a maxima, we'll probably just, and we think we're going to open this way. It's going to be concave left. So it looks like this is going to be a minima, and it's just going to barely brush the y-axis at y equals 2. Just to check whether that's a minima or not, let's look at the slope of the line to either side of it. So we'll look at dx dy, and we'll evaluate, let's say, just above that critical point. Let's evaluate at dx dy equals 3. Right? Dx dy at y equals 3. And here we are just going to get 4 times 3 minus 2 times 1. And so this is going to be 4 times 1, which is 4. Right? And on the other side, on the low side, just below this critical point, we'll have dx dy, and we'll evaluate it at y equals 0, and that will give us 4 times 0 minus 2, which will give us minus 8. So it looks like our slope with respect to dx dy, right, is going to be coming in, and it's going to be, let's see, above the critical point. We are going to be we're going to have a positive slope of x with respect to y. So as y increases, right, as y increases this way, our x is going to increase this way, right? So we're going to be going up this way. And below the critical point, as x increases, or let's say as y increases, right, x is going to be decreasing, right? So we're coming in this way. As y increases towards the critical point, our x is getting drawn in, and then as y increases, x is going back out here, right? So we have a minima here, and let's put it on the graph. Let's say right here this is y equals 2, and we're going to have some sort of parabola here, opening to the right. All right, and so let's go ahead and graph it, and then let's go ahead and see what value, right? What value of x would make y 0, right? And for that, we're going to go ahead and we're actually going to invert this problem and make y as a function of x. So for now, let's just say that it does cross this axis at some point, right? So here's our function here, right? So this is y as a function of or excuse me, x as a function of y. Right? Now let's go ahead and we'll invert the problem, and we'll say, okay, if we rearrange this problem to make y a function of x, we will have this equals, let's say y equals equals plus or minus, right? I have this in my notes here when I did this problem previously. X over 2 plus 2, right? So each of these, I guess, signs, each of these parts of this square root, one's the plus root x over 2 and the other is minus root x over 2, is each of them is going to be 1/2 of this parabola here. So what we're going to have, right, is we're going to have a y-intercept of plus 2, right? So when x equals 0, right? When x equals 0, right, we will have y equals 2, right? And then as x increases, we will have a positive half that grows as a square root of x over 2, so it's going to grow a little bit slower than the regular square root. So it's going to kind of maybe go up like this, and we'll try to make it kind of look like the other one we already did, right? It's going to grow up like this. Right? And and then we'll have a negative reflection of that, right? So we'll have this kind of come down like this, right? So this is, this graph is really just positive, the shape of the graph is just positive root x over 2, right, plus 2, and this is minus x root x over 2 plus 2. And now to find what this crossover is here, we'll look for a root of this function, and we know it's going to be on the minus root x over 2 curve. So let's go ahead and say 0 equals minus, let's write it like this first, root x over 2 plus 2, so we have minus 2, right, equals minus root x over 2, root 2, excuse me, right? Okay, so we have, let's square both sides, right? Well, let's move this over here first. Let's get rid of the minus sign, right? And let's move this over here. So root 2 equals root x, right? And then we square both sides and we will get x equals 4 times 2 equals 8. Alright, so this is the point 8, 0. X, y equals 8, 0. Okay, and just to check that, let's plug that back in here, and let's have root 8 over root 2. This is minus root 8 plus 2. Does this equal 0? Well, this equals minus root 4 root 2 over root 2 plus 2. These cancel, equals minus 2 plus 2 equals 0. Yep, so it looks like that's a valid solution. So that's two ways to go about solving this function, x in terms of y, or x as a function of y, and then y as a function of x. And if you're following along with the solution manual, you'll notice, I forgot to mention this in the last video, but for questions 9 and 10 in the graphing math section of Guide 1, those solutions are actually missing in the solution manual. So if you're going through it, you'll notice that. So don't go looking for it in the PDF. It's it may be there on another page. I haven't found it, but I'll look again later. But anyways, it's not where it's supposed to be. So just figured I'd mention that so you don't go nuts looking for it. All right. So there you have it. Just a quick solution, two different ways for this this function.